Alright, hey guys. Today I want to talk to you about completing the square. And it's a little bit of a difficult concept for a lot of students, so I'm going to take things slow and start off at the beginning. And for completing the square, the beginning is thinking about easy binomials. What I mean by easy binomials is the first kinds of things that your teacher talked to you about when they taught you about factoring. So let's think about some easy, I'm going to put it in quotes, easy binomials. Because after you learn how to complete the square, all binomials are going to be easy, but right now these are the easiest. These are things like x squared plus 18x plus 81 is equal to 0. So factoring makes a question like this really easy, right? Because I'm going to make that look like a little bit more like an 8. So what multiplies to give 81, because it's 81 times 1, right? And adds to give 18? Well, it'd be 9. So conveniently, it's x plus 9, x plus 9 is equal to 0. Another easy one, x squared plus 12x plus 36. So what multiplies to give 36 and then adds to give 12? 6, right? X squared plus 6 is equal to 0. And one more, probably the easiest one, would be x squared plus 4x plus 4 is equal to 0. What multiplies to give 4 and adds to give 4? 2. So you got, not x squared, x plus 2, x plus 2 is equal to 0. So these are what I want to call easy to solve binomials. The next thing I want to say is that you can take each of these and write them in this form, where it's some binomial squared set to 0. So all of these could be written like this. Because what I want to talk about next is the fact that all of these have something in common, and you guys are going to see what they have in common pretty quickly. So I want to write easy binomials have the following form. It's always some number where the following is true, some number a, right? Easy to solve binomials always look like this. So in this case, a was equal to 9. And in this case, a was equal to 6. And in this case, a was equal to 2. And you can see if you took the following quantity, x squared plus x plus a squared, and you factored that out, you would find that this is true. This is the general form of an easy to solve binomial. And that's important, right? Because it's interesting, but then also I want you to note that if I gave you some easy to solve binomial that was equal to some number, it doesn't even matter if it's a perfect square, some number, I asked you to solve for x, you could do that, right? Because you just take the plus or minus square root of what's on the other side, get rid of this 2, and then you'd move over the a. So that means that easy binomials are really easy to work with for a reason, right? So, as you know, we're not going to stay in easy binomial land. We're going to move on to harder to solve binomials. But that's okay, because the whole goal of completing a square is taking a harder to solve binomial and turning it into an easy to solve binomial. Something like this that we can work with, where even if we have something on the other side, we can just use our square root laws and then find x anyway. So as an example, let's look at x squared plus 20x plus 40 is equal to 0. Okay, so you can't factor this because what multiplies to give 40 and adds to give 20? Nothing, right? Unfortunately. So we're gonna have to get a little tricky here. The goal is to make a harder to solve binomial look like an easy to solve binomial. So we want to get the left side of the equation to look something like this. Something like an easy to solve binomial, so that we can use this and then find x anyway. So the first thing I want to do is move the 40 over. So you subtract 40 from both sides. And it's already starting to look a little bit more like this. We're just missing one thing. We're missing an a squared, right? So I'm going to go ahead and write that in. Plus a squared is equal to negative 40 plus a squared. So this is true when what's true? Just looking at this side of the equation, what's the difference between that and an easy to solve binomial? Well, I mean, hopefully I scrolled up and down enough for you to see that the only thing that's different is the 20 and the 2a, so they gotta be equal. And if this is true, then we know we can find a really easily, right? What's 20 divided by 2? It's 10. So then, now we have an a to work with, and we can plug that in. We'll leave the 20x. A squared, 10 squared, is equal to 100. So we know a squared is 100. And this side becomes 60. So what's this side? Well, now it's easy to work with binomial, right? Because we got rid of this coefficient and we kind of forced it into an easy to solve binomial. But that's what we're trying to do. So what multiplies to give 100 and adds to give 20? Conveniently enough, 10. So this side of the equation is equal to x plus 10 squared. It'd be x plus 10 times x plus 10. And then I just shortened that into x plus 10 squared because of what we talked about up here, right? Take an easy to solve binomial, it always has this form. So hopefully you notice that now we're exactly where we wanted to be, where we have an easy to solve binomial and then some number on the other side. So it's going to be pretty easy to work out what to do from here. You can just take this plus or minus square root of both sides to get rid of the 2, and then you just move the 10 over. So that's our final answer, and we've just completed the square using the fact that easy binomials always have the following form, and we can do this with them. So I'm going to give another example, a slightly harder example. Hopefully to illustrate that you can do this with any binomial. So any binomial you can't factor, as well as the ones you can factor, you can do this with. So an example of a slightly more difficult binomial to solve would be 4x squared plus 4x minus 3 is equal to 0. So this one's pretty wonky, right? Like you can't solve this by factoring. For sure, like what's equal to negative 12 and adds to give 4, negative 6, and 2, I guess, but we'll use completing the square. So first thing you want to do is think about, okay, how do I turn this into an easy to solve binomial? Well, easy to solve binomials have the following form, and they never have a coefficient in front of the first x. So what we want to do first is get rid of this 4, the coefficient. So we'll divide by 4, not x to the 4. So this turns into x. This becomes negative 3/4. That stays 0. 0 divided by anything is 0. So we're still working along. We're trying to make it look like an easy to solve binomial. We get to this stage. What's left? Well, there's the a squared. So we'll add a squared to both sides. And this looks like an easy to solve binomial, except for the 2a, right? So this must be true when, what, 1 is equal to 2a? So a has got to be equal to a half. And we can plug that back in. What's a half squared? That's a fourth. So this is going to be a fourth. A fourth plus 3/4 is 1. You know what, I'm just going to write that out. And this side is going to be x plus a half squared, right? Because if our a is a half, and we have a perfect binomial, which we know we do because we forced it into a perfect binomial, we can write this. X plus a squared. So if we have this and we have a, we can always write this. So I'm going to write a is equal to half, x plus a half squared. This is going to be 1. And then we're back at the easy to solve part, so we'll get rid of the square root. Don't forget to write your 2's correctly, but then also don't forget the plus or minus 1, the plus or minus, because you're taking the square root of 1. So anytime you do that in an equation, you end up with a plus or minus. And then we'll bring the 1/2 over, and then you end up with this. This is kind of generally what your answer is going to look like when you complete the square, unless the numbers work out more nicely, but they won't if they ask you to complete the square specifically. So that's completing the square, and it works on every single kind of binomial you could make up. It's going to give you an answer no matter what. Sometimes it'll give you imaginary answers, but that's a video for another time. In general, you'll end up with real answers that make sense. I hope that this video helped you, and this review packet, or not review packet, but this MS Paint document will be up in your resources. And have a good day, guys.